talking to you. This is Goddess of Science Physics, and today we are going to do some collision problem exemplars. And before we start, I just wanted to review with you a little bit the two different types of collision problems. We have you have two objects beforehand, both of them moving, or perhaps only one is moving, but they come together and bounce off each other and both continue on separately. That's called an elastic collision. And then we have the type of collision where you have the two objects, they collide and they get stuck together, and that's the inelastic. And you know that this is the equation that you're going to use when they're stuck together because the masses are joined and you only have a single velocity afterwards. Okay, so let's get down to this. So a coconut has a mass of 1 kilogram, is traveling at a velocity of 4 meters per second. It rolls over a stationary rotting banana with a mass of 0.25. The two get stuck together. Immediately, we should be thinking inelastic collision, inelastic. And continue rolling. What type of collision is this? Well, because they're stuck together, it's going to be inelastic. So that also tells us which of those two equations that we need to use. So that's great. Let's go back and fill in some of the known stuff that we have. Now, because there's usually a lot of information associated with these problems, what I usually do is I take my box, my known box, and I say before on one side and after on the other side. So let's take a look. So all the beginning stuff is all before. So mass of a coconut. So usually when it actually gives me a name of something, I usually try to show that the mass belongs to the coconut by using a lowercase c rather than the M1, V1, M2, V2, the numbers. It's a little bit easier. If you want to use the numbers, I'm okay with that, as long as you know which one is which. So the mass of the coconut is 1 kilogram. The velocity of the coconut is 4 meters per second. We also have a rotting banana, so we got a mass of a banana equals 0.25 kilograms, and the velocity of the banana is stationary, so the velocity is going to be 0. It says they get stuck together, so afterwards the masses are not going to change, so we'll just make arrows over that. But what does change is we have a velocity of both of them together, and that's what we're trying to find. Okay, so let's take a look at our equation here. So we said that this was for inelastic. So we have mass of the coconut, velocity of the coconut, plus the mass of the banana times the velocity of the banana gives you, or equals, mass of the coconut plus the mass of the banana. Because they get stuck together, they're now considered one mass. And then we have the velocity of both. Okay, so let's start substituting in. So we got 1 times 4 plus mass of the banana is 0.25. Velocity of the banana is 0. That makes that easy. Equals mass of the coconut after is still the same. And we're going to add to it the mass of the banana. And then we have the velocity of both. So first thing, this looks really complicated, but once you boil all this down, it's actually not too much. So because it's 0.25 times 0, we can get rid of that. We don't have to pay attention to that. So we got 4 times 1 is 4 equals 1 plus 0.25, so that's 1.25 times the velocity of both. All of that boiled down to just that little bit. So now we're going to divide both sides by 1.25, 1.25, and when we do that, we end up with a velocity of 3.2 meters per second. Okay, well, that's the first one, so that's an inelastic collision. Let's try an elastic collision. Move the paper up here a little bit. Okay, So a raw turnip has a mass, and same thing before, after, just so that it kind of keeps things straight. And I know that some of you aren't really big on the writing down what you know, but it's really, really kind of important. So a raw turnip has a mass, so the mass of the turnip is 1.2. Is flying through the air with the velocity of the turnip is 10 meters per second. This is in kilograms. It crashes into a bath sponge, so the mass of the sponge is 0.4 kilograms. That is stationary. So again, good for us, velocity of the sponge is 0. The collision is elastic, so the masses are not going to change, so we'll just bring those over without actually having to write them. The bath sponge moves away with a velocity. So velocity of the sponge is 5 meters per second. What's the velocity of the turnip afterwards? Okay. This equation is actually pretty easy to remember because the beginning part and the end part are exactly the same. So we got the mass of the turnip times the velocity of the turnip plus the mass of the sponge, the velocity of the sponge. This is all before. And then we have an after side equals mass of the turnip, velocity of the turnip after, plus the mass of the sponge, velocity of the sponge. This is when it gets very helpful to have this little box already, sorted out, so you can just take 1.2 and substitute it in for the mass of the turnip, times 10, which is the velocity of the turnip, plus 0.4, which is the mass of the sponge, times 0, equals mass of the turnip didn't change, 1.2, and we're trying to find the velocity of the turnip, plus mass of the sponge, which is still 0.4, times the velocity of the sponge now is 5. So let's shrink this down and see what we got. So we got 1.2 times 10 is 12. This we don't need to worry about because it's times 0, equals 1.2 times the velocity of the turnip, plus 0.4 times 5, which is actually 2. So now we have to subtract 2 from both sides. So we got 10 equals 1.2 times the velocity of the turnip. Divide both sides by 1.2. And you end up with a velocity of that turnip of 8.33 meters per second. Okay, well, that's it for the 2 different types of collisions. I hope that helped you out a little bit. That's it for this time. Have a good day.